Welcome to section 4 of chapter 4, part 1. And in this video, we're going to look at trigonometric functions of any angle. We're not just going to focus in on the first quadrant. We're going to expand out into the second, third, and fourth quadrant. Now, let's say we have an angle here that is just somewhere in the second quadrant. Let's go ahead and call that angle theta. And so if this is theta, and let's say the length of this is r. Now, typically we've been dealing with the radius here being 1, and we've only been dealing with the unit circle. But let's say it's not a unit circle. Let's say the radius is something other than 1, like 3, 7, or even some irrational number, whatever it may be. We know that this radius is related to the x and y value by the definition of the circle. And that's x squared plus y squared equals r squared. Or another way to look at it is Pythagorean theorem, saying that, well, we could look at this x distance along the negative x-axis here and the y distance along the positive y-axis here, use Pythagorean theorem, and that gives us r, and that's going to stay constant at all times. Now, typically, we've said in the unit circle that the sine of theta is equal to y. Well, that's still true, but it's not just y. It's going to be y divided by r. Okay, so sine of theta is y divided by r given whatever radius this is, whatever length of this piece is. And then cosine theta will then be x over r, and that would give us tangent of theta is still going to be y over x. And then we can look at secant theta. Well, secant theta is just the inverse of cosine, so that's r over x. And cosecant theta is the inverse of sine, so that's r over y. And cotangent theta is the inverse of tangent, so that's x over y. Okay, so really this isn't anything different than what we've been doing. It's just now we're going to have an angle like 125 degrees instead of something between 0 and pi, or an angle like 7 pi over 4, instead of something between 0 and pi over 2. Okay? In this example, we're going to have a point, negative 2, 3, that is on the terminal side of theta. All right, so what does this look like? Well, it's at negative 2 and up at positive 3. So here's the point right here. And so this is theta. This is what we're talking about. And our goal here is to find sine of theta, cosine of theta, and tangent of theta. Okay, well, let's look at what we have here. Well, this is our x value. This is our y value. Well, let's find our r value. R is going to equal the square root of x squared plus y squared. This just comes from Pythagorean theorem and the definition of a circle. All right, so r is going to equal 4 plus 9, and the square root of that, which will be radical 13. Now, we can't simplify that any, so we're just going to leave that as radical 13. So if we want to find sine of theta, well, sine of theta is y over r. Well, what's y in this case? It's 3. What's r? Radical 13. Okay, we want to rationalize that, so that's 3 radical 13 over 13. So let's look at cosine theta. Cosine is x over r. So x in this case is a negative 2, and once again we're dividing by radical 13. So when that's rationalized, we get a negative 2 radical 13 over 13. And then finally tangent is y over x, so that's a negative 3 halves. And so these are our 3 trigonometric functions for this given angle. Now, what were we given at the beginning? Remember, we were given a point. So we're told that this is the point. Basically, this is a point on the circle, so that defines the radius. I want to know at what angle is that the point on our circle. Okay, let's look at another example. Let's say we're given that tangent of theta is, let's go negative 5 over 4. Okay, so tangent of theta is negative 5 over 4, but let's also say that cosine of theta is positive. It's greater than 0. And we want to find sine of theta and secant of theta. So we need to find these two pieces here, sine and secant. Well, what does this tell us? Let's digest what we're being told here. Well, we're being told that tangent is negative 5/4. Well, what is tangent? Tangent is y over x. Now, keep in mind, cosine has to be positive. So what does that tell us? That tells us that x has to be positive. And for y divided by x to be negative, that means that y must be negative. Okay, so that tells us that y is equal to a negative 5 and x is equal to 4. So if we wanted to graph this and take a look, we could graph the 0.45, so that's 1, 2, 3, 4, 1, 2, 3, 4, 5, and it's 4, negative 5, excuse me. And so this is our angle right here. Okay, so we want this full angle because we're going through this point 4, negative 5. Okay, and does this confirm x is positive, so that means cosine's positive. Remember, ASTC. Cosine is positive down here in the fourth quadrant. Sine and tangent are both negative in the fourth quadrant, and so that confirms what we have so far. Now we want to find sine. In order to find sine, we know sine is equal to y over r, and secant is equal to r over x. Well, both of these we need to find r, and we don't have r, but we know r squared equals x squared plus y squared. So r is going to equal the square root of 16 plus 25, which is radical 41. And we can't simplify that, so we're going to leave it as radical 41. So that means that sine of theta being y over r is going to give us a negative 5 over radical 41, which rationalizes into negative 5 radical 41 over 41. And secant theta, which is r over x, that's going to be radical 41 over 4. And those are our two pieces right there. Okay, next we're going to talk about this idea of a reference angle. Okay, so these reference angles come into play when we're in the second, third, or fourth quadrant. When we're in the first quadrant, our angle is the reference angle. But the reason for a reference angle is, well, let's take a look at this. Let's say we have some angle in the, let's just go second quadrant, and so some angle right here. Okay, now this is theta. And theta is bigger than pi over 2. Okay, this is pi over 2 right here. And so we're bigger than pi over 2. But, you know, we could still represent this same thing, and it actually acts very similar to all the trig functions act very similar to the same angle that we have right here. And we call this theta prime, or our reference angle. And this is our reference angle. Okay, so now in this case, what would that equal? Well, this is just going to equal pi minus whatever theta is, because it's our supplement to our angle. Okay, well, let's look at a different situation. Let's say we're in the third quadrant. So let's say we're down here somewhere. Okay, and so this is theta. And our reference angle is still going to be this little piece right here. This is theta prime. So if this is theta, that big angle is theta, that little angle just off of the x is theta prime, our reference angle. Well, how would we find that? We would find that from taking theta minus pi. So notice the difference. When we're in the second quadrant, we take pi minus theta. But when we're in the third quadrant, we take theta minus pi. Now, why is the reference angle these two positions here? Well, the reference angle is always the angle that our terminal side makes with the closest x-axis. So we take the terminal side and we find the acute angle that it makes with the x-axis. And that is our reference angle. Okay, So let's look at an example. Let's say we have an angle like 5 pi over 4. Okay, well, let's graph that. 5 pi over 4, oh, this is pi. 5 pi over 4 would be right here. Okay, this is 5 pi over 4. Its reference angle is going to be this little angle here, the acute angle that it makes with the closest horizontal axis, and in this case it's the negative x-axis. All right, so what is that angle? Well, since this is bigger than pi, subtract pi and we get pi over 4. So the reference angle, if this is theta, then this is theta prime, our reference angle. So to find your reference angle, you have to determine what quadrant is your angle in. And if it's in the first quadrant, then theta is equal to theta prime. Okay, our theta, our reference angle is just our angle. All right, if we're in the second quadrant, then our reference angle is equal to pi minus whatever the angle is. Okay, so say it's something like 100 degrees, it's just past 90, well then its reference angle is going to be 80 degrees, 180 minus 100 to give you the 80 degrees. Or if it's in radians, then you take pi minus whatever the angle is. If it's in the third quadrant, then our reference angle is going to be our angle minus pi. Okay, and we saw this in the last diagram here, that if we're just before pi, we subtract our angle from pi to get our reference. But if we're just past pi, then we're going to subtract pi from our angle to get our reference. Now, what if we're in the fourth quadrant? Well, if we're in the fourth quadrant, then our reference angle is actually going to equal 2 pi minus theta. Okay, so and we see this from, let's say we're something right here, and this is our angle theta. Well, our reference angle is actually this angle right here. This is theta prime. Well, that's just 2 pi minus whatever our angle is, and that gives us what's left. Okay, so let's try a couple of these. Let's find the reference angle for theta. So find theta prime for the given theta. Let's say we have something like 213 degrees. How about 8 pi over 5? And let's have another angle of 310 degrees. Okay, so we want to find, these are our angles, we want to find the reference angles. So we have to identify what quadrant are we in. Well, 213, where does that fall? Well, that's bigger than 180 and it's less than 270. So that gives us the third quadrant. Now, what do we do with the third quadrant? Well, the third quadrant, we take the angle minus pi, which in this case, since it's degrees, we want to take 213 minus 180. All right, and so when we do that, well, what do we get? We get 33 degrees as our reference angle. Okay, now 8 pi over 5, well, where does that fall? That's bigger than pi. It's less than 2 pi, but is it bigger than 3 pi over 2? And it is, in fact, bigger than 3 pi over 2, and I'm going to explain what if you didn't realize that, or if you made a mistake in just a moment. So this falls in the fourth quadrant. And so really, what are you asking? You're asking, is 8/5 bigger than 3/2? All right, and 8/5 is bigger than 3/2. So it's in the fourth quadrant. So what do we want to do? We want to take 2 pi minus our angle of 8 pi over 5, which this is really just 10 pi over 5, and so we get 2 pi over 5. Now, let's say you made a mistake and said this was in the third quadrant. You didn't want to graph it and you just said, oh, this is third quadrant. So you go through and see that, well, with third quadrant, we want to take the angle minus pi, and so you take 8/5 pi minus pi, which is just 5 pi over 5, and we end up getting 3 pi over 5. Well, this should tell you that, wait a minute, there's an issue with this. That is bigger than pi over 2. 3/5 is bigger than 1/2. Reference angles always have to be within 0 and pi over 2. Okay? If they're not, then we did something wrong. So this right there is a tip that, hey, 3/5 pi is bigger than pi over 2. So that's got to be wrong. It's not in the third quadrant. It's got to be in the fourth. Okay, so let's look at 310. Well, once again, that's in the fourth quadrant. So we want to take 360 minus 310, and then that will give us our reference angle of 50 degrees. Okay, now you're going to practice this in class, and you're going to work on page 318. And on 318, I want you to do numbers 1 through 8, 15 to 22, and 37 to 44. So complete these in class today, and then also there's going to be another video, part 2, that you're going to watch tonight for homework that will help you to do tomorrow's lesson.